Hello, everyone. Welcome back to SAT Math Question of the Day. So, we are changing things around. We found a mother load of questions from the College Board that gives you practice for the SAT. This comes from what's called the educator side of the SAT, College Board websites. Anyway, let's go. Here's our question of the day. Please try it, pause the video, come back, and we'll do it. Okay. The table gives the coordinates of 2 points on a line in the XY plane. The y-intercept of the line is k minus 5 comma b, where k and b are constants. What is the value of b? Ooh, this is certainly not a straight, immediate question.
Okay, so let me share my approach.
Go ahead.
It deals with slopes and intercepts.
Yep.
And what is given to you is data that could tell you to how to compute. You have enough data in the table to tell what the slope is. So what I'm going to do is write the standard slope-intercept form for the equation of a line. And I'm using capital M and B because the stupid question has a lowercase b in the data. Okay? Now, I can figure out what M is. M is, well, when y goes up by 7, when x goes up by 7, y changes from 13 to 15.
Yep.
And so M, the slope, is when you go up by 7, the change in y is the new value of y minus the old value of y.
Okay.
And I could compute that. That is negative, how much? 28.
28.
Divided by 7, also known as minus 4.
Okay.
So I have figured out that the equation of the line in question is y equals minus 4x plus b.
Yep.
Now, I relate it to the rest of the data. The y-intercept is k minus 5 and b, lowercase b, where these are constants. And the question asks, what's the value of b? So I just put in the data. Where the slope, the y-intercept means it's a point on the line.
Yep.
Don't even have to think of it as being the y-intercept. So when x is equal to k minus 5, when x equals k minus 5, then y should equal lowercase b.
You have wrong. X is 0. X is 0.
Hold on. The y-intercept. The y-intercept is k minus 5 b. Oh, wow. Okay, so the y-intercept means that it's the point where x equals 0.
Right.
So therefore k equals 5.
K is 5, right?
Right? And when k equals 5, we have b equals b. And they ask, what is the value of b?
Seth has hit a brick wall because he hasn't thought about exactly how to do the problem backwards or.
That's right. Okay, so I'm stuck. I am stuck.
Seth is just following his nose, doing what he thinks he should do without a main strategy. It would
Yeah,
be.
yeah.
This is a hard question. By the way, let me tell everyone, we are changing our modus operandi. We're only going to be doing hard questions for the next number
Good.
of
Yeah.
months.
Okay.
Okay. So
Hmm.
Seth has yet to plan this out. It seems to me that this is a problem of two equations, two unknowns. You have two unknowns, k and b, which means you're going to need two equations. We have one equation already, which is good, that this thing equals 0. So we have a one equation, one unknown problem. We don't know b, so we need another equation. But this point is on the line, and we know that k is 5. So 513 is on the line. If 513 is on the line, that gives us enough information to solve for b. Problem solved. Problem solved. So the other
So when
way
k
to
equals 5, b equals 13.
Yeah.
Well, when k equals 5, then y equals 13.
Yeah, when k is 5, y is 13. So that's it.
Oh.
That
So
gives
the
us a one
answer is
equation,
b
one
equals
unknown.
13.
Well, let's see. Let's do it slowly. 13 is equal to negative 4 times 5 plus b. Right? Am I doing this right? 13 equals negative 4 times 5, which is negative 20 plus b. So 13 is equal to negative 20 plus b. So b is 33.
Which b?
Our b. Oh, that's a different b. Oh, wait, hold on. Which b are we doing? Which b are we...
You're the one that said b. There's a lowercase b, and I added an uppercase b. And you wrote an uppercase b.
Oh, right. So, okay, fine. So, this is... Okay. So, the y-intercept is... Oh, yeah, the y-intercept is here. X is equal to 0. B is equal to the y-intercept. So, wait. X is equal to... This is the equation. What is it, Seth?
Yeah, that's not... The point is not on the origin. The y-intercept is not necessarily the origin.
This is the... Okay, we know the y-intercept. The y-intercept is 0. Actually, we don't know the y-intercept. We know the y-intercept is 0, comma b. That is the y-intercept. Right?
Right.
Yeah. And if this is the equation of the line... Well, the equation of the line has to go through this. It's so I would have written it. I don't know if I would have brought in this thing. The slope is definitely negative 4. So what are you saying, Seth?
I have to stare at this some more. I don't know.
Wait a second. It can't be that hard, okay? It can't be that hard. We know the y-intercept.
I need some quiet to think about it. I don't know.
K is 5. B is the y.
So the y-intercept is what they said. K minus 5 and b.
Yeah, we just need to know the y-intercept.
So we can conclude from this, since the y-intercept has first coordinate of 0, we know that k equals 5.
K is equal to 5. Absolutely right.
Okay, so k equals 5.
Yeah,
good.
But if this is the
good. So we know that k equals 5.
Yeah.
Right, we know that k equals 5. Therefore, we know 2 points on the line.
Right.
We have 1 point is 513.
Right.
This is on the line, and the other is 5 and 7 is
12, comma negative 15.
yeah, 5 and 7 is 13, right?
No, 12.
5 and 7 is 12. Okay, so
12,
12
negative 15.
and negative 15.
Right.
Okay?
Right.
And then, so we want to find the y-intercept.
Yeah. So you have 2 points.
So he has 2 points on the line, and we want to find the y-intercept. Okay, good. So we the y-intercept is we want to find the y coordinate of the y-intercept.
Right. Yeah.
In other words, in the Brown equation, we want to find out what b is.
That's right. Yeah.
And so we just plug in one of the points that we know, and that will tell us what b is.
That's right. I did that.
Right. So you did that.
Yeah.
So where'd you do that?
Over here. I will change color. The orange area. The orange.
Okay, there we go. So the orange area, you plugged in x equals 5 and y equals 13, and you got the b at the end, 33. And therefore we could solve for b.
Right.
It's 13 plus 20, which is 33.
33. B is 33. Yeah. Yeah.
So the answer is B.
Yeah.
Okay. Good.
Yeah.
Got it.
Yeah. I mean, I would have started this question from a point of view of 2 equations, 2 unknowns. You don't know K, you don't know B. So therefore, you just start hunting for relationships. And there's a pattern. We always talk about the 4 questions. Pattern. Huge pattern sitting here. Yeah. Oh, what a big pattern. What's the big pattern? Seth, what do you think the big pattern is? The big giveaway, the pattern that if you realize it, the problem opens up very quickly. And if you don't, you're screwed. Sorry for the crude language. The pattern is that this thing is equal to 0. The y-intercept means that x value is equal to 0. So even though you have 2 equations, 2 unknowns, one of the equations is easy if you see the pattern.
Yeah.
Pattern.
You call it. Yeah. If you see, you need to see the relevance of a certain fact.
Yeah.
Related to the data that's given. And so I wouldn't call it a pattern. You need to actually recognize that the relevant information is that the x coordinate of the y-intercept point is 0.
Right.
And so the fact that you're told that the y-intercept is k minus 5, you need to conclude from that the unknown k is a constant, that to find b, it's a good idea to find k, and then that the fact tells you k is equal to 5.
Right. Yeah.
So I think your idea is your insight to look at it as a system of 2 equations. A system of 2 unknowns, of which you don't know the equations.
Right. Yeah. Then you start
is an excellent insight.
Yeah.
Because then you seek. Okay. Well, there are 2 unknowns, and then the question to solve for yourself is, what are the equations?
That's right, and you put all of your energy as if it's the only thing in the world.
So instead of giving you a problem where they give you 2 equations and 2 unknowns and ask to solve it, they're giving you 2 unknowns and they ask you to find the equations.
Yeah, or the relationships that allow you to get those. Right, exactly.
Well, those are the equations.
Yeah, of course. Now, how I actually would have done this problem, Seth swooped in and did it. I didn't have the chance to actually figure out how to do it. But when Seth wrote this, I said, whoa, K is 5. I don't know how long it would have taken me to see that. I don't know.
Yeah.
I don't know because I never had the chance, which is fine. That's what we
Uh,
share. We share
yeah.
solutions. I can't be honest and say how long it would have taken me to see that. I don't know. But that breaks the problem open. So once you see K is 5, now it's just a now you didn't even need necessarily this. Once you realize that K is 5, then all of a sudden it's just a problem of 2 points. What's the equation of a line in slope-intercept form of these 2 points? Which are these 2 points? And you could use the usual method of getting the slope and figuring out what B is.
Good.
But it's definitely a good idea to try to plan out in a problem that's not obvious. If it's follow your nose, obvious problem, fine. But if it's not a bad idea to plan out exactly what your strategy is before you start writing stuff, which Seth actually didn't do.
So
and
this is an interesting question.
Yeah. So that's good. If we want to feed Seth interesting questions, again, from now on, for the foreseeable future, we are only going to do hard problems. But the presumption that if we go over the concepts before hard problems, then you can use these concepts to do the easier ones.
Well, there are plenty of other videos on YouTube of easy problems.
Plus everything before August 19th, everything between when now and when we started on August 19th, 2023 or 2022, whenever we started, 2022, you can go and see us do easy problems.
If you want easy problems, the best place to get easy problems is the Khan Academy videos of the SAT.
Of our, you can find it. Okay, anyway, so let's go through, just because now we're doing hard problems, that doesn't relieve us from our responsibility of answering the 4 questions. Plus today's Throwback Thursday, so hold on if you want to watch that. Calculator. No, I mean, God, not really. I mean, you do have a calculator, but hopefully you don't need a calculator to do some of these calculations, but why not? Starting with a guess, that doesn't apply. This is not a multiple choice question. How does this question differ from a school test? You would almost never see a question this convoluted on a school test.
Well, these questions come from a resource published by the College Board that's intended for teachers.
Yes.
So if you're lucky, your teacher might draw questions from it and present them in class.
Right. That's right. By the way, the College Board is so adorable. They give an ID to every question. It's very cute. Okay. Now the big idea. Now the most important question. Whoever wrote this question, what were they trying to see if you knew how to do, other than stay calm when faced with a complicated question? Yeah, so what would be the main ideas here? You could do this problem multiple ways. My approach would have been 2 equations, 2 unknowns, but you can see that there are multiple ways to do this problem. But certainly the concept of slope is important. And it's not so obvious that the slope doesn't depend on K, but if you just calculate the slope using the slope formula, you realize the K's cancel. Seth had a great insight there, that the slope actually does not depend on K. But they want to make sure you know how to do slope, equations of a line, what the y-intercept is, the fact that the y-intercept, the x is 0. If you were writing this question, Seth, what would have been your motivation to test this? What would have been what you would have wanted to see people knew?
Well, that the y-intercept is a point with 2 coordinates.
Yeah.
And it's characterized by the first coordinate being 0.
Yeah.
X coordinate is 0.
Right.
And then there's another term for the y-intercept, which is the y-coordinate of the y-intercept. So we have to it's an unfortunate multiple meanings of the same word. Right? So do they, in y equals mx plus b, do they call b the y-intercept?
Yeah, usually. Yeah.
Usually. But they also the coordinates, the point on the plane where the line crosses the y-axis, that is a point. It's not a number,
Right.
and it's called the y-intercept.
The other thing that I think, unfortunately, they really want to see what they know how to do, which is how to do a more complicated problem, how to think about a problem that's more complicated. Because they could have easily
it's a non-standard problem.
It's a but it also requires some really higher level thinking as opposed to just knowing how to get the y-intercept. Because they could have just given you 2 points. Yeah. They could have just given you these 2 points and said, hey, what's the y-intercept? Mm-hmm. Okay, fine, that's straightforward. This is not a straightforward problem, so they're also asking you to develop your higher level thinking. But you can't really develop the high level thinking until you get the basics down. So if you're not sure about the basics, go to Khan Academy and do all sorts of problems on y-intercept and equations of a line. And then it's time to start developing the higher level thinking. And one structure I like to use in higher level thinking to make things a little more easier to sort of think about is if you have 2 unknowns, think about that you need 2 relationships, 2 independent equations to get your 2 unknowns. Anyway, we now, something we haven't had in a long time, I don't know if we've ever seen it, we now have the official SAT explanation as to how to do this problem. And Seth loves to criticize, Seth loves to comment on this, and I sort of like it too. So let us see, first of all, let's see what the answer is, and let us see how they suggest doing it. Okay, here we go. The answer is 33 according to the SAT people. Rationale. Interesting way to say, here's the answer. The correct answer is 33. It's given in the table. The coordinates of the 2 points are got those things, right? The y-intercept is another point of line. Slope computed. Okay, so they get the slope, and they get -4. So up until... Oh, and I lost my annotation. Oops. Oh, I'm going to have to annotate in y-coord. Okay, there we go. So, okay. Okay, now, so up until here, we got that. Now, it is given that the y-intercept line is this, substituting -4 for m. See, they're doing it another way, aren't they? They're doing it another way. It's given that the y-intercept of the line is this, substituting -4 for m, and the coordinates of the points into the slope formula yields this.
Yeah.
Which is equivalent to this, which means you get b. So what they did is they didn't even use the y equals mx plus b. Okay, so they're doing 2 equations, 2 unknowns also. Right?
Okay, well, let's see what they calculate the slope. And then they use the 2 points.
Yeah. These are the 2
of the table. They put that into the slope formula.
Yeah, here it is.
B is unknown. They just plugged it in.
These are the 2 points.
And their calculation yielded, I want to put, let me pick a distinct color. Really, really remarkable color. Purple. Look at that. Yeah. When they did the calculation, when they plugged in the slope formula, the K disappeared.
Yeah.
Okay. Well, I think the insights that you and I, Joel, discussed are much better explanation of are much better rationale for solving this problem.
Yeah, you really had to pray.
All they did was, this is a routine method. They just took 2 points They plug them into the slope formula, knowing what the slope is, and it's so what would happen if they didn't tell you that k minus 5b was the y-intercept? This wouldn't have worked.
Wait, how is k minus 5 the y-intercept? Even in
k minus 5b is the y-intercept point.
Yeah, but
that's part of the data.
Why? I know, but how is that used in the question? How is that used in the question?
Okay, here the k's cancel again.
No, but how is that used?
That's a good question. Yeah, I'll let me look. How is it used? The y-intercept is another point on the line.
Right. They're giving you 3 points on the line. They're giving you this one, and k.
Okay, it is given that the y-intercept is wait, it is given that the y-intercept is k minus 5b. Yeah. Well,
I don't know.
So they don't use. They don't use.
Yeah.
That they don't use the data that k minus 5b is the y-intercept. Other than k minus 5 and b are points on the line.
Right. So in other words, I wrote here in red. I'll change it to orange. These problems should really have been given as 3 points. If 3 points were given on a line, what is the y-intercept? Oh, what is b? What is b?
Wow.
What is b? What is b? Given 3 points that are on a line, what is b? That would be the same question.
Yeah.
Because if that's the case, you figure out what the slope is.
No. They give you 2 points on the line. All of the x coordinates of the 2 points are a number plus k.
Right.
So by interpolating, what this data tells you, that if you increase the x coordinate from k to k plus 7, then you decrease the y value by a certain amount.
By 20. Yeah, we already said that.
Hold on. Now they're asking you, what do you get? What do you get if instead of increasing k by 7, you decrease it by 5?
Okay.
Well, decreasing k by 5 to figure out what you get, what you do is you take minus 5, multiply it by the slope, which they figured out was minus 4. So decrease k by 5, you take, the slope is minus 4, right?
Right.
Decrease k by 5, so you're going to change the y value by minus 4 times minus 5, which is 20.
Yeah.
Going to change the y value by 20 by adding 20. We know the y value for k. So the y value for k minus 5 is now the old y value of 13 plus how much it changes, which is 20. So it's 13 plus 20 is 33 is the answer.
Right. So there we go. There's the graphical approach. The graphical
Yeah.
approach means that K13 is the black line.
Yeah.
We go left down by 5 because we want to know what what 5 fewer is. So it's 20 higher. It's 20 higher on the y side because it's 5 times 4 because it's a negative slope. So if we go negative 5, it's 20 higher, so it's 33.
Yeah.
That's the graphical approach. Great. Wow. So this is what happens when you have a more complicated problem, is that there's more than one way to do it. Okay, so we already went through 3 or 4 ways to do this problem. So
we figured out that B is 33, and it just so happens with the data that's already given, when the point that they're talking about happens to be the y-intercept. The y-intercept is whatever k was plus 7 is the x-coordinate of the y-intercept.
It seems to be completely irrelevant. The way they're doing it and the way we just did it is completely irrelevant that it's the y-intercept. That's sort of interesting. That's sort of interesting.
So again, I'm sorry. We calculated the point on the line. Calculated the point on the line where the x-coordinate is k minus 5. We calculated that to be the y-coordinate to be 33. But with the data given, that point happened to be the one where the x-coordinate is 0. In other words, k was equal to 5, so k minus 5 was 0. And the point they told you about was the y-intercept. So the problem is, it's just coincidental that the data they gave, k minus 5b, is a point on the line. It's they could have just said it's a point on the line, and you could, and it would have
exactly.
The data that they gave you implied that point is the y-intercept.
Right. It didn't matter whether it's the y-intercept or not if you do it the method they did it. And the other method, the graphical method, the accepted. So anyway, so there's a lot of stuff. So this is what happens when you have a more harder problem. There's more than
so
one
this
way
is
to
a
do
case
it.
of a problem that's difficult because it contains redundant data.
Yeah. Right. Exactly. Yeah.
Yeah.
Redundant. Yeah. A little more. Some information that's not completely necessary, but
they give you information that can be implied,
right?
That could be omitted, and the problem would be the same. Which entails that if they made it, that they could have made a mistake, and they made a constant mistake. They made a mistake in one of the constants. Then the problem would be inconsistent.
Yeah, but they didn't do that. Okay, so I guess we're done with this, right?
Yeah.
So it's an interesting problem. It kept Seth interested, which is good.
Yeah.
Okay, so today is Throwback Thursday. Notice we're changing the format, so it's maybe a little. Let's see how we're going to do this. Okay, Throwback Thursday. Throwback Thursday. Here we go. We gotta kill the Zoom annotation. Oh, well, maybe we're just not going to be able to do that. Okay, so just excuse everyone. Just ignore that. Okay. So then can you kill the Zoom? Can you kill the Zoom annotations? Kill all on Zoom? On the annotation.
Well, that's my annotation.
Yeah, annotation. Just say kill all. But hopefully it's...
Okay. Yeah, let's see. Let me think. How do you do that?
Okay, well, anyway, while Seth's thinking, which is never a good thing, we will talk about this. This is a throwback question. This is a throwback question from before 2016.
Did it?
where they had, thanks Seth, they had column A and column B, and you are supposed to say whether column A is always bigger than column B is always bigger than column A, whether column A and B are always the same, or whether there's not enough information to determine which one is bigger. Okay, so we don't see these questions anymore. And this question attracted me only because it looks like you really have to think, as opposed to just learning stuff you knew in learning stuff that you did in school, which is consistent with the test before 2016. Oh no, that's not a good sign when Seth says, "Oh wow." Okay, here we go for our Throwback Thursday question of the day. Questions that come from a test maybe from 20 years ago. Okay, and let's go to a smaller font. Okay. Square S and equilateral triangle T have equal areas. Okay, let's draw a picture. Square S and equilateral triangle T, even though it's not drawn to scale, that's fine. Oh, and these are different sizes, okay? Let's not make that mistake. Have equal areas. So A1 equals A2. Okay? Okay, so now we have a little picture. The length of the side
this is
S,
leading me.
So there's S.
What's this? This is leading me to. It's leading me to write the formula for the common area A.
I agree.
Yeah. What's that area? The common area.
Yeah.
AREA equals the length of the side is S. So.
Yeah. So that we have.
But
that's easy.
There's some function.
That's right.
Given the length of the side of an equilateral triangle, we need to know the formula for what the area is.
Right. Yeah, which...
Oh, gosh, that's a little complicated. It is, of course, order T squared.
Right. The question is...
So it's some constant times T squared.
And there's a radical 3 involved.
Right. So that constant is... Yeah, that when T equals 1, you could figure out the constant. So you need to figure out the area of an equilateral triangle whose side is 1. So and how much is that?
I need to go back to the test book to see whether they give a table of the area of an equilateral triangle.
Let's figure it out. It's an equilateral triangle, so...
No, wait.
So,
they do not
so
give
you drop an altitude...
Shh. This is important. They do not give that on the back in those days. They did not give it on the reference sheet. The area of an equilateral triangle. So we need to derive it. Yeah.
All right. So the base, the base is 1. And the height is the square root of 1 minus 1/2 squared.
Yeah.
Oh, that's a mess. So this is a square root of 1 minus 1/4, which is a square root of 3/4.
Right.
Is the height. And the length of the base is 1, but the area is 1/2 times the base times the height. So the area is... So K equals the square root of 3/4 times 1/2 of the base, which is 1/2, which is also known as the square root of 3 divided by 2 times 2.
Right. So it's the square root of 3 over 4.
The square root of 3 over 4.
Yeah.
And so what do we have? The area. So if S squared equals the square root of 3 over 4 times T squared, and so it depends on whether the square root of 3 over 4 is greater than how it compares to 1.
Of course, it's less than 1. It's less than 1.
It's less than 1.
So this number here
so K is
less than 1.
K is less than 1. So therefore S is less than t. K is less than 1. K is less than 1.
Right. K is less than 1.
Yeah, K is less than 1. And this is telling you a comparison between S squared. S squared is, wait, is this right? S squared equals KT squared.
Right. Yeah.
K is less than 1, so KT squared is less than T squared.
So T has to be greater than T has to be greater than S.
Yeah.
Yeah. In order for this to be true,
Yeah.
T must be greater than S. If K is less than 1, then T must be greater than S.
Yeah.
So B is the answer.
Good.
So can you have done this? It's dangerous to use intuition, but you would maybe. I mean, if you're good with geometry, you can argue that.
Oh yeah, definitely, definitely. The equilateral triangle properly fits inside of the square.
No, but
yes, you can do that intuitively. You know, here's your picture. Hold on. Here's your picture of, you know, so if we want to compare an equilateral triangle and a square whose side, where the side of the square is 1 and the side of the equilateral triangle is 1. Or in other words, the side of an equilateral triangle is S and the side of the square is S. This blue thing is our square. The equilateral triangle will look something like this. You know, its height is less than the length of the side.
Yes.
One side of it lines up with one side of the square, and so the triangle is a smaller area. Right. And therefore, for the areas to be equal, the length of the side of the triangle must be bigger.
Right. That's the way they probably wanted to see when they wrote this question in 2000, 20 years ago. That's probably the way they wanted you to think. Like really smart, really, really smart, as opposed to what we did, which was sort of the stupid brute force way of doing it. This is brute force, not a good thing. This is more IQ. They are testing that back then, 20 years ago, they were looking for people with high IQ. And this is the high IQ solution.
Yeah.
And just, you can see that in order for the orange triangle to be as large as the blue box. In order for the orange triangle to be as large as the blue box, the orange base side, it's got to be bigger than the blue base.
That's the way. That's a good way to hear.
This is probably the way they wanted you. This is the way they.
Yeah.
First of all, you're richly rewarded on the SAT, considering the fact that this section had 15 questions on it. And, you had 2 minutes. Wait, you had 2 minutes? No, you didn't have a whole lot of time. You basically had you had about a minute to do this question on average.
Yeah.
So, you would lose a lot of time if you did it the way we did. So, anyway. So, let's see how they categorize this. Whether they call this an easy or hard question. Let's see. See how they categorized it. Boy, back then the test had 7 sections. Oh, it was painful test back then. Excuse me. Okay, so it's question 10, section 3. Question 10, B. Yeah, B means B1 is bigger. and they call it difficulty level 4. So moderately hard. 4 out of 5. 4 out of 5 difficulty level. 5 meaning the highest. Okay, we are done. Wait, 45 minutes today, but we're getting used to these harder questions. So brace yourself for hard questions for the next, I don't want to say few years, but maybe for the next few years. Okay, everyone, so that's it. We don't do our analysis on these questions. I don't do our 4 questions. Okay, anyway, I'm Joel. I have a PhD in mechanical engineering. My brother Seth is a PhD in math. We're here to try to give you different insights on how to do the SAT math questions. We're now moving into the questions that are really just harder questions. And we hope that they're rich, and we will go over different ways to do them and give insights. And hopefully this will give you ways to also do the easier questions. That's about it, right? If you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. It's also on the title of our YouTube videos. And, of course, please leave comments to us. We take all the comments very seriously, and we try to respond to all of them. Everyone, I hope you got something out of today's discussion. Okay, anything else, Seth?
Nope,
that's it. Okay, hope to see you tomorrow. Take care, everyone. Bye.
Hey, bye-bye.